In this assignment, we need to implement the mergeSort algorithm using a linked list instead of arrays. We can use any kind of linked list structure, but just to keep it simple, we're going to be using singly linked lists here. We won't be using low, middle, and high. We would normally do this with mergeSort, and this is kind of how you would think about it. But for here, we're just going to find the middle of the list, traverse through the linked list, and keep count of the number of nodes, breaking up our list into two, and then they're both null terminated lists based on our node count. We have some part of the code right here that can help us. We need to make sure to account for when the head is null or when there's only one item in the list. This is important because otherwise it could break our list. So next we are going to look at some documentation on this. So for mergeSort, we have these notes right here that we can look at in further detail, or we can just skim over them really quickly. But these two are important in understanding how it works. And then this is code that will help us in solving for this. So we have this page, and then lastly, this page, which will help us imagine it and think about it a little bit more. But back to the actual code, we're going to just be referencing these instructions in the code itself. So to the left, we have our output right here. We have a list that we can hard code. This is the list before sorting and then after sorting. So we'll full screen this, and then we're going to go into here. So before sorting, we have this list like this, and then after a merge sort, it's obviously just going to be assorted in ascending order. Our class is going to look like this. So we have our public class main, and this is going to be the main class. We're also going to need a class node, which will create our linked list, and then a class mergeSort, which will be doing the actual sorting in. So first we have our main, and we can do a little bit of a skeleton on how we're going to code this. First, we need to make an initial unsorted list, and we can hard code this ourselves. I'm going to code this as an array. So we're going to do int. We have these two braces, and then we're going to call this unsorted, and then we're going to set it equal to a list of numbers. So I'm choosing these as my numbers, and then our array is going to look like this. So this is our initial unsorted list. Now, we want to make a new instance of our mergeSort class. So we're going to come down here, and we'll just do sorting, and we're going to make a class in a second, but we're going to call it mergeSort, and then we're going to set sort equal to a new mergeSort, and then we're going to pass in our unsorted list. That way we can put this in the constructor, and we can convert our array right here to a list. So if we hover over this, we can click create class mergeSort. This will actually in Eclipse make a totally new Java file. So instead of doing that, we're going to come down here, and while we're at it, we're going to make our class node, and then we're going to finally make our class mergeSort, and then we can close it off like this. So these are our two classes. We're in our mergeSort now, and we have to make a constructor to take this. Before we do that, let's deal with the node class. That way we can actually make our linked list. So when we have a node, we have an initial data. So it's going to be public, and then we're going to call this int data. And then we're going to have public node because, actually also this should be a lowercase n. We have a public node, so it basically calls this class again. And then this is going to be the next value. And that's what really connects our nodes together. In here, we're going to need a constructor so we can pass data in. It'll be public node. We're going to have int data here. And then inside of here, we are going to set this dot data equal to data. And that's it for our node class. Now in the mergeSort, we know we need a head and a tail for a linked list. So we're going to do public. We're going to have node, and this is our head. And then we're going to have public node, and then next. So these are our two values right here. And as a matter of fact, we're not ever going to be seeing this next outside of this class. And since we never see it outside of this class, we can make this private. We will see the head because we are going to call it, or we're going to actually use it in one of the method calls in our main method. So the head has to be public. So after this, what we're going to do is we're going to make a constructor that will take our unsorted list. We know a constructor is going to be public, our class name, so public merge. We're passing in our array, so it's going to be int, and then we're going to call this unsorted, and then we're going to be inside of here. Now, we are going to need to traverse this as the instructions say, and then we're going to add this to our node head. So in here, I'm just going to traverse the array, and we're going to do this inside of a for each loop. And the way a for each loop works is basically instead of writing a for loop, which is int a is equal to 0, a is less than, we would just do unsorted dot length, and then a plus plus. We are going to keep the int a is equal to 0, and then instead we're just going to run this for unsorted. And what this is doing is it's going to, we also need to change this to a colon instead of a semicolon. And what this is doing is it's creating the a is equal to 0, and matter of fact, we don't even need to set it equal to 0, because we have int a, and then we have this array. Int a starts at the 0th index, and it's going to run the entire length of the array. So that's going to be inside the for each loop, and then we're going to be adding to a linked list. Now there's two scenarios that we need to keep in mind. The first one is if the head is null. In that case, we're going to need to assign the head and the tail. So if head is equal to null, we are going to be inside of here, and then we need to make a new node. So we're going to do node, we'll call this nn for new node, and then we're going to set this equal to a new node, and we're going to pass in a. And remember, a right here is the index, and since we're doing a for each loop, it's getting the value at here, and it's passing this inside of here. So it's going to look like this. And then we're going to set head equal to nn, because it's the only thing in our list. And also, since it's the only thing in our list, tail is equal to nn. And so that is our first thing. Also, I called this next. I mean to call it tail, because this is going to be the end. Now we have an else statement, and the else statement is for if we have even one thing in here. And if we have even one thing in here, we're just going to add to the back of it. So we're just going to surround this in an else statement, and we're going to say node nn, because we need to make a new node. We're going to set this equal to node, and then we're passing in the index at which our element is, so it's getting the element. And then we're going to set tail.next equal to the new node, and this is because the current tail is the one before this. So tail.next is the new node, and then after we do this, tail is equal to our new node. And so this is it for our constructor right here. Now what we can do is just print this out since it's in our linked list. So what we're going to do is we are going to write out a printing right here so we know what we're doing. And then we're going to do a sysout, and then inside of our sysout we're just going to write list before sorting. And then we're going to come down onto the next line. And then we are going to need to call a toString method to actually print this out. So before we make the method inside of our mergeSort, we can just call it here. We'll do sort.toString. And then what we want to pass in is the head after we've gone ahead and we've added the unsorted array into it. So we'll go line by this. So in this line right here, we create our array. In this line, we create an instance of our mergeSort class, and then we're passing in our array. Once we pass in our array here, it's going to go into here, and then our sort instance right here, it's going to hold all of these in a linked list that's in the head, because we're setting head equal to this, and then we're just going to set tail, which is the next thing every single time, equal to the next value. So we're going to do sort.toString, and then we're going to do sort dot, and then we're just going to grab the head. Now we need to make a toString method, so we can hover over this and we can click create method. We'll scroll down here and we have our method right here. Our method is going to be void because we're not returning anything, we're just printing. It's called toString, and we're passing in node, and then we'll just call this n just for ease of typing. Inside of here, we're going to use this node n and just print out a normal toString. This is a fairly simple toString method. We're just running through this for loop right here, and we're going to be printing out every single value. And I've only included this bracket, this if statement, else statement, and this comma just to make it look a little bit nicer, but that's not all necessary. If we were to run this though, we would come out with this. So list before sorting is this, and we can see that it is equal to the list we have up here. That's the easy part. we've put our array into a linked list, and then we've written it out. Now we actually have to sort it using our mergeSort. So I'm going to come back up to the main method, and then inside of here, I'm just going to do a sysout, and then we're just going to make a prompt list after sorting. And then we're going to come down onto the next line. And then what we're going to want to do here is we want to obviously put whatever we're going to do inside of a toString method so we can print it out. So we're going to do sort.toString. And then inside of our toString, we are going to have sort dot, and we need to make a method to sort this. So we're going to call this sorting. We'll do sort.sorting. And then inside of our sorting, we're going to pass in the head value. So we're going to do sort.head. What we're doing here is we're taking this head, we're passing it into this sorting method right here, and then we're going to sort it, and then we're just going to print it. So in the end here, we should be returning a node inside of here. This should return a node, because if we look at our toString, it takes a node as parameter. And so we need to create this method. So we create method sorting. We come down here, and we have public node sorting node head2. I'm going to change the head2 name to be, instead of head2, I'm going to call it current. So this is going to change to be current, and then we can delete all of this auto-generated stuff inside of here. So this is our method. First thing that we need to do before we sort it is see if our list is empty or if it only has one thing in it. If it's empty or only has one thing in it, well, we're just going to return itself because it does not need to be sorted. Inside of here, we're going to have if current is equal to null or current.next is equal to null. Then all we're going to do is return current. So that's pretty simple to understand. That's just if our list is empty or if it only has one thing. Next, what we're going to do is key to the mergeSort. We're going to get the middle so that we can split it. Under here, what we're going to have is a node, and we need to find the middle. So we're going to set mid equal to, and since this is a lot, we'll put this in its own helper method, and we'll call it get mid. And then what we want to do is pass in our current value, because the current value is currently our entire list. So we're going to pass in current, and then what we can do is create a get mid helper method. So it's going to be right here. It's private because it's only being accessed inside of this class. So inside of here in our get mid, since we're calling this multiple times, we're going to call this multiple times because our sorting method is going to be recursive. We need to see if there is nothing. And if there is nothing, we're just going to return. So if current is equal to null, we are going to return current. So we're returning itself. Now we're going to traverse through the list with one node going up twice as fast as the other. So we're going to have two nodes in here. We're going to have like a middle node that's going to see the mid node, and then we're going to have an end node. The end node, every single time we traverse, is going to be incremented twice, while the middle node will only be incremented once. So eventually when we get to the end of the list, the mid node will be half the list and the end node will be the entire list. And that way we know we can just return the mid node. So we're going to make a new node here. It's going to be node mid node, and we're setting this equal to current. So this is going to take whatever we have right here. We want this to be equal to the first value, so it's really grabbing the head. Current is equal to the head currently. And so after we do this, we're going to need a for loop to go through here. So we need to make a new node. It's going to be end node, and we're setting this equal to current.next. So we can get the next value, and then we're going to run this as long as our end node does not equal to null. And then we're just going to do end node is equal to end node every single time this for loop runs. This is already one incrementation. And since this is, this should actually be end node dot next. Good catch, because otherwise this will go on forever. It'll be an infinite loop. So we have end node is equal to end node dot next, and that's one iteration. Now, if the end node dot next, so the next value does not equal to null, we can add on to here. And then we're just going to say that our mid node is equal to our mid node dot next. And then we can also say that our end node is equal to end node dot next. And so we're going to increment our mid node once and increment our end node twice every single time this for loop runs. And then once we're done, we're going to break out of this for loop, and then we're simply going to return the mid node because that is what we actually want. And so this is now storing the middle node. We want to break this into left and right sides. So we're going to say everything from the current head to the mid is our left. And then everything after this is our right. And so to get our right, we're going to make a new node and we're going to call it mid next. So this is the value after our mid. And we're going to set it equal to mid dot next. And so this will get that value. And then from here, well, we don't want anything after mid, because remember, this goes from the head to the mid, and then it stops right here. And then this goes from the mid dot next to the tail. And so now knowing this, what we can say is, well, we don't want anything after a mid, so that means our mid dot next is going to equal to null. So we break everything off after that. Now is when we officially want to break into left and right. This is where we're going to use recursion, because we want to run through these steps for every single middle that we're going to break into. Once we have our left side or our right side, we'll just go with the left side for this explanation. The way that mergeSort works is that we have one side and then we continuously break it into halves, and then we're just going to sort those individual small values at the end. And so what we can say here is that the left side, so node left, is going to be equal to sorting. And then here we're going to pass in the current value, because remember we want this is from the head to the mid. So we're passing in current here. And then the node right is equal to sorting. And then we're passed in node next. And this is the mid next value. So we're getting everything from the next to the tail, everything after the mid to the tail. And so we're going to do this so many times until we have no more we can split. And then once we have no more we can split, we are going to return these separate sides, and it's going to be stored in our left and stored in our right. So once we do this, we just need to sort this. So we can make a new node and we'll call it sorted list, because once we do this, we'll be sorted the list. And this is equal to sorting, and we're passing in the left and we're passing in our right. Once we do this, also this is a new method. Just because it has the same name doesn't mean it's the same method, because it has two parameters where this one only has one. And that's the only reason why we can name it the same thing. And so once we come from this sorted list, once everything is done after we've written it, we are going to return the sorted list. And that will complete our program. But before we do that, we actually have to make this method. So we're going to click create method, and we're going to create this method right here. Now it is private, again, because it's only being used inside of this class. It's nice when there's a lot of abstraction. And so we have this getMid that we already did. I'm going to put it underneath our getMid just to keep it in order. So we're going to be inside of here. I'm going to get rid of the auto generation. We're going to keep the left and the right sides. If you look at the instructions, right here, when we have the head and node A and node B, and then the merging of node A and node B, and then the mergeSort node head, this is really these left and right sides. Just keep that in mind. The wording's a little bit differently. So from here, what we want to do is first we want to make sure our left or our right side isn't null. If our left or our right side is null, then we can just return it because there's nothing inside of it. But we are going to return the other side. So if the left is equal to null, that means our left side is empty, and then we just want to return the right. So we're going to say that our return should be the right. And then we're going to do the same thing. We're going to say else if, and then we're going to do right is equal to null. Then we're just going to return left. From here, we want to make a new list to store our values in, and then we're going to eventually return this. And what we return is going to be stored inside of sorted list, which will then return the sorted list. So we'll be inside of here, and then we're going to say node, and we're going to call this final list, because this is our final list, and we're setting this equal to null. The only reason why we're setting this equal to null right now is because we're just declaring it, but we have to initialize it since it's a local variable. And then inside of here, we're going to say, well, if the left.data, and when we do .data, we get the actual value at our node, is less than or equal to the right.data, then what we're going to have to do is say that the final list is equal to the left. So if the left side, right, is less than the right side, that means the left side is smaller. And since we're sorting this in ascending order, well, that means the smallest has to be stored in the final list first. And then after this, we're going to store the next value. But instead of storing it, we're going to compare it and store whatever is really the smallest of the next. So inside of here, we're going to do a final list dot next. So it's going to be put in the next spot of our final list. And then we're going to use recursion, where we have sorting. And then inside of here, we're going to do left dot next, because we've stored left already. So we get the next value. And then we're going to just pass in the right again, because that one hasn't been touched. It's still the greater of the two. Now we need to see if we have this other case where the left dot data is actually greater than the right dot data. And if this is true, then we're going to be in here. And then obviously the final list is now going to be equal to right, because right is the smaller of the two. And then final list dot next, we're going to be set this equal to sorting, where we actually pass in left and then right dot next. So it's just like the previous one, we're just kind of reversing it. Now after we do both of these, we're just going to return final list. And so this will be stored into this right here, and we're going to go over all that in a second. So this should be our code so far. We have our toString, we have the sorting, we have our getMid, we have the other sorting, we have our constructor, the node, and we have our main. So now we can try and run this, and we can see that we have sorted our list. Now we can go over all of the lines of code. So we have our public class main, and in our public class main, we have this main method. We have our initial unsorted array list, so we just hard coded this in here. We are then going to sort this. Well, this isn't actually sorting. We're creating a new instance of our mergeSort class, and then we're going to pass in our array. The reason why we're passing in our array is that if we look at our constructor, which is right here, we can see that we're just converting this into a linked list. And then we're storing this linked list inside of the public node head. And also we're using the private node tail for this as well. And to even do both of these, we have to have a node class. And so we're going to come back up here, and we're just going to sys out list before sorting, and then print sort.toString sort.head. And sort.head calls this entire passed in list. Now the toString we wrote all the way down here, and this toString just basically prints it out. It's super simple, and we have some brackets and commas for neatness. And then if we want, we can go back up here. The next thing that we do is come to this list after sorting, which is really the heart of this code. We have sort.toString, and then we're going to do sort.sorting sort.head. So we're going to pass in our current list into sort.sorting, and then we print it out with the sort.toString. So going into sort.sorting, we are going to go to this first one. I did it in order. This is why I do it in order. In here we have public node sorting. We're going to pass in our head, but this is going to change every single time to a new head. So if this is equal to null at the first time, we're just going to return null. This is also our base case, since this is recursion. We always need a base case, otherwise, like a loop, it will run on forever. And so this is our base case. Now we need to get the middle so we can split it. If we use node mid equal to get mid current, we can come down here. We have this private class where we pass in our node head, or the current value. If this is null, we are just going to return it. And then otherwise, we are going to just traverse here, and then we will get our middle node through this traversal. Then from here, we're going to come back up here. And then inside of here, we have get the middle, so we can split. So we're gonna have this node mid equal to the current mid value. And so what we're saying here is, well, we're gonna go from our head to the middle. And so that's the left side. That's the reason why we get the middle, so we can split it into left and right. And then this mid next is equal to mid dot next. And so this is gonna go from mid next to tail. So the value after mid to the end, and that's our entire right side. And then since we don't want anything after this, we actually have to set this next value to null so we don't get the entire list inside of our mid. Then we're going to break into the left and right here, and then we're going to use recursion to go over this sorting all over again every single time. And then we are going to pass in our left and right once they have no more values in them, when it looks something like this. When it's done right here. Once it's done, we're going to pass it into here. And then we're going to use a method to sort this, and then we're going to eventually return this. So going down to our sorting right here, we have this method where we pass in the left and the right. This is our base case. If the left is null or the right is null, we are just going to return these two things. From here, after that, we want to make a new list to store the values and eventually return it. So we have node final list, and we're initializing that to null. And then we need to put values in it. So if left.data is less than right.data, that means left is smaller. And since we're dealing with ascending, we're putting this in first. And then we're going to use recursion and say that final list.next. So the next value in our linked list is equal to all of this over, but we get the next value on the left side and the same right value so we can compare them. And then we do the same thing if the left is greater than our right, and then we finally return it. And so that is going to be our code for the sorting class and the code for our node and our main method.